Which set is correct for boiling point gradation? Which one is correct for boiling point gradation? Let us see the matter. Which set is correct for boiling point gradation? First of all, let us see about methane. Methane. This is tetrahedral geometry. Here, electronegativity of carbon is 2.5, hydrogen 2.1. There is a bit difference in electronegativity, which is 0.4. So, this bond is a bit polar, partially positive in charge, partially positive in charge, partially positive in charge, and partially positive in charge. And carbon is partially negative in charge. So each bond is polar, but dipole of each bond cancels out dipole of another bond. So ultimately this is non-polar molecule, as it is symmetrical tetrahedral in shape. Dipole of each bond cancels out dipole of another bond, and the molecule turns into completely non-polar molecule, and as a result there is no intermolecular attraction force. For this reason its boiling point is very low, minus 161.5 degree Celsius, as it is symmetrical tetrahedral in shape. Each bond dipole cancels out another bond dipole, and no intermolecular attraction force. Boiling point is very less, which is minus 161.5 degrees Celsius. Now let us see about ammonia. Ammonia, which is trigonal pyramidal in shape, another ammonia molecule. Here electronegativity of nitrogen is 3.1, hydrogen 2.1. Electronegativity difference is just 1. So this bond, nitrogen hydrogen bond, becomes polar. Hydrogen becomes positive in charge, nitrogen becomes negative in charge. Hydrogen becomes positive in charge, nitrogen becomes negative in charge, as nitrogen's electronegativity is higher than hydrogen, and here electronegativity difference is just 1. So in this case intermolecular hydrogen bond is formed. Due to this hydrogen bond, in this case boiling point will be a bit higher compared to methane, and here boiling point is minus 33.3 degrees Celsius. That is, boiling point of ammonia is greater than methane. Now let us see about hydrogen fluoride. Hydrogen fluoride. Here hydrogen fluoride, another hydrogen fluoride. Electronegativity of fluorine is 4.0, hydrogen 2.1. Electronegativity difference is 1.9. Very high difference. Because of this high difference, it is negative in charge, hydrogen positive in charge. Hydrogen positive in charge, this is negative in charge, and negative charge density is higher. Positive charge density is higher because electronegativity difference is higher. But In this case, one molecule of hydrogen fluoride forms maximum 2 hydrogen bond. Maximum 2 hydrogen bond. Since one molecule of hydrogen fluoride forms maximum 2 hydrogen bond on an average. That is why its boiling point is not very higher. This is 91.5 degree Celsius. Now let us see about water. Water. This is bent or V-shaped. In water, every water molecule can form 4 hydrogen bonds. In water, every hydrogen molecule can form 1, 2, 3, 4. 4 hydrogen bonds. That is why to break these 4 hydrogen bonds, it requires high amount of heat energy. That is why its boiling point is higher. And this is 100 degrees Celsius. Since every water molecule can form 4 hydrogen bonds, 2 bonds with hydrogen and another 2 bonds with 2 lone pairs of electrons present on the oxygen atom. In this way, every water molecule can form 4 hydrogen bonds. So, high amount of heat energy is required to break these 4 hydrogen bonds, and that is why in water boiling point is higher, which is 100 degrees Celsius. That is what is the gradation. Lastly, methane. Methane's boiling point is lower than ammonia, after that hydrogen fluoride, and then water. So methane, ammonia, hydrogen fluoride and water. This is the correct answer. Which set is correct for the boiling point gradation? That is, set B is correct for boiling point gradation. Thank you for watching.